Okay, going over a few problems for the review for the exam. From chapter 1 we have distances along a number line and midpoints on a segment. So in any case, getting started, to find the distance from point B to point C, we're going to take the two coordinates for those 2 points and subtract them. If we start with a larger number, we don't have to have absolute value signs. We're automatically going to get a positive answer, and the distance has to be positive. So the distance from B to C is 17 minus 3, which is 14. Likewise, the distance from A to point B, the next problem, is 3 minus negative 2. You have to be careful when you have negative numbers. Subtracting a negative is the same as adding a positive, and we get the second answer is equal to 5. And we can use the same procedure as the first 2 problems for the third problem, and the distance from A to point C would be 17, the coordinate of point C, minus negative 2, which is the coordinate of point A, which gives you 17 plus 2, which is 19. Now another way of confirming that you have the correct answer there is distance from A to B added with the distance from B to C should equal the distance from A to point C by using the segment addition postulate. So that's a different way of coming up with the same answer. The coordinate of the midpoint of segment BC. Now if we just look at segment BC, let's get rid of some of this, and we'll look at segment BC. Any segment has exactly one midpoint, so to find the coordinate of that point, you can do it a few different ways. The way I like to do it is to take the 2 coordinates, 17 and positive 3, add them together and divide by 2. You're finding the average of the coordinates. So that gives you 20 divided by 2, which is equal to 10. Then you can check your answer by saying the distance from 3 up to 10, 10 minus 3, that distance is equal to 7. And from 17 to 10, 17 minus 10 is also equal to 7. So the definition of a midpoint is satisfied. It is a point on the segment, and it is the same distance away from point B as it is from point C. Next problem. Given that point M is the midpoint of segment AB, solve for the value for x. So if this distance right here, as stated, is x plus 7, then if M is the midpoint, the distance from M to point B is also x plus 7. And using the segment addition postulate, the distance from A to M added with the distance from M to point B should equal the distance from A to point B, which is 3x minus 8. So we'll simplify and solve. 1x plus 1x is 2x, 7 plus 7 is 14. So if that equals 3x minus 8, I'll subtract 2x from each side of the equation, and at the same time, or on the next step, add 8 to each side of the equation. The 2x's cancel, and we get 22 equals 3x minus 2x is equal to 1x, so simply x, and the 8's cancel, so we get x equals 22. Then you should check your answer. So 22 plus 7, this first segment is 29. Let's say it's 29 inches. And the same for the other segment, because it is a midpoint. It has to be the same distance on each side of the midpoint. Plugging in 22 here gives you 3 times 22, which is 66, minus 8, which is 58. And you should note that 58 is equal to the sum of the other 2 segments. 29 plus 29 is also 58. So because the answer checks, 22 has to be the correct answer. And the next problem, dealing with angles. We can have similar problems dealing with angles. We could have values expressed in terms of x like the previous problem, and use the angle addition postulate instead of the segment addition postulate. The only difference would be you'd use the word bisector for an angle bisector instead of a midpoint. But doing a basic problem dealing with angles, if you look at the diagram based on these 2 angles given as equaling 81 and 47, you should be able to state or notice that those 3 angles add to equal 180, So if the first two angles, 81 and 47, total 128, if we subtract, we should get the other angle is equal to 52. The other angle in this case being BGC. Once we have that angle, and you know that vertical angles are congruent, if we have one 81-degree angle on the other side of the diagram, angle DGE, that also has to be 81. If the angle we just found, BGC, is equal to 52, then angle EGF is also equal to 52. And we have another 47-degree angle over here. As a result of doing that, you should be able to answer all of the questions. BGC is this 52. AGF is this 47. And angle FGD, this angle right here. Let's get a different color. And the angle with the blue arc being drawn across it is simply equal to 52 plus 81, which is 133. Hope that helps, and we'll continue in a minute.